Good morning, students. Today, let us see decomposition from Unit 1 in our subject problem solving using C++. Right. Now, basically, you all know that in any scientific method, whether it comes under physics or chemistry, first we will form the hypothesis. Then we will plan the experiment. Then we will execute the experiment. Then we will evaluate the results. It means that whatever task is given to you, you are doing in a step by step manner. Right? That is, you divide, right? First, you form the hypothesis, you plan, you execute, and you evaluate results. So, here comes the decomposition. In 1973, Polly advocates that first, initially, you are supposed to understand the problem, devise a plan, execute the plan, review, and extend. Don't panic. Don't be put off by perceived size and complexity. So, even if the problem statement is very large, very complex, you should not panic because we are supposed to solve this complex task into simpler tasks by dividing them. Then, resist the urge to jump straight into writing a solution. Always, we cannot directly write a solution. We should understand, right? Then, we should divide the complex task into simpler one, or you should divide the big task into small tasks. Then, we will execute it. Right. So, a heuristic is a specific strategy in problem solving that usually yields a good enough answer that not necessarily an optimal one. Examples, it includes trial and error using a rule of thumb or drawing an analogy. Right. So for devising a solution, there are something we should keep in mind. First one is the quality. Multiple solutions are there, so find the best one. So according to an algorithm, right, our algorithm should be efficient one, that is time and memory consumption should be less. The second one is collaboration, seek out the views of others. Then iteration, improve your current solution, right? It is an iterative approach. You cannot find a solution which is static, it should be dynamic. If suppose if we need to update, so we can once again we can refine, we can reiterate, and we can find a new version of it. So the major points are quality, collaboration, and iteration. Right. Now, competition thinking promotes one of these heuristics to a core practice that is called as decomposition. Right. So, decomposition is an approach that seeks to break a complex problem down into simpler parts that are easier to deal with. The basic algorithmic strategy is divide and conquer strategy. Right, something seen in numerous places outside the computing. The best example is binary search. Right, so linear search will be searching each and every element. In binary search, we'll be dividing the entire concept, entire array into two, and we will search in any one half, and it continues. Okay, and moreover, it uses a recursive procedure. Right. Yeah, now what is recursion? It is a technique used to simplify a problem. It defines a solution to a large complex problem in terms of smaller simpler problems of the same form as the original problem. This is a powerful idea and one that is heavily used in computer science. And the simple definition of recursion is the function which calls itself. The best example is factorial program. Right. So n factorial, we will write it as n into n minus 1 factorial. For example, 5 factorial, we'll call it as 5 into 4 factorial. Now 4 factorial will be 4 into 3 factorial. 3 factorial will be 3 into 2 factorial. 2 factorial will be 2 into 1 factorial. Finally, 1 factorial will return 1. Or even in other case, you can have 1 factorial as 1 into 0 factorial. Now, all the function calls will be push. Stack is a data structure used, right? And all the returns will be pop, right? So recursion means a function calls itself. The problem is reformed as a series of smaller problems that, while simpler, might still be too complex, in which case they too need breaking down, and so on. Visually, this gives the problem definition a tree structure. So we'll be breaking down. till we find a simple smaller task. Now decomposition aids collaboration. So if I say I decompose a task into subtasks, you should integrate this subtask to find the solution. So if you decompose a problem well, so that subproblems can be solved independently, that different people can work on different tasks, possibly in parallel. The other effective strategies are, we should think critically. You should solve a concrete instance. You should find a already existing problem or related problem, and you should work backward to find the best solution. Finally, so decomposition and generalization are related. Whereas decomposition involves breaking the problem down into smaller parts, generalization involves combining those smaller parts, that is, integrating those smaller parts. These actions are not inverse of one another. When you generalize the individual parts, you are not putting the problem together again in the same way as before. The point of generalization is to look at the decomposed parts and find ways to make the solution easier to handle and more widely applicable to similar problems. Thank you, students.